All right, this is a little project that I've been kind of contemplating for, I don't know, probably a year or two now, something like that. I saw one somewhere, a friend of mine has one, and I decided I wanted to make my own version of this. And this is kind of how it started out. I looked at his and thought about it and how I might want to do it. And so it starts out as a kind of a chicken sketch that evolves a little bit. And there we're starting to kind of throw some dimensions on things. This is about looking at some of the angle relationships of this and whatnot. And I'm just showing you this stuff for background, kind of how a project starts. But here's kind of ultimately how it ends up. And this is modeled in SolidWorks here. And what this is I call it a sensitive drill feed. And it fits in the tailstock of a lathe. This has got a Morse taper here, and that was one of the things I was thinking about. Do I want it to be a 3 or a 4 taper or whatnot? Well, ultimately, I decided to make it a 2, so that it can be used on small lathes, and you can always adapt up. Was the thought, and it's kind of hard to go down from a 4 to go on a Monarch EE or something like that. So anyway, the way it works is fits in the tailstock of the lathe. This is bushed. This is a sliding fit in this bushing here, and this is your hand lever here to feed the drill. Okay, so you get it's a limited travel. It only has a 3/4 of an inch of travel, something like that, which is plenty for small drills, but you get a better feel than you do by winding the tailstock. Okay, now there's some interesting things that have kind of come out of this. So let's look at this is the most complicated part here, the lever itself. And I was going to machine that out of steel in one piece. And then it's funny, you meet people and you start talking about this kind of work. Well, I met a guy, and he was. I don't know, he was complaining about engineers, so that was the discussion, and he mentioned that he had something 3D metal printed by a company back east called Shapeways, and so we were talking about it, and he said, yeah, this bracket was like $12. I said, $12 for a metal printed part, and anyway, so I explored this, and this is a result of that exploration. Okay, this is a 3D printed metal part, right? Which is this lever right here. Ah, wow, it's almost 1-to-1. Look at that. That's pure accident. I just noticed that. So here it is, right? And this thing is real. It's 420 stainless with a bronze matrix in it. And it's pretty hard. I've touched it with a file, and it's a real part, and it's plenty strong. I put this in the vise, and we'll do that a little later and give it a little wank and see how it goes. But just to put this in perspective, this was $78. Okay, now, like I said, I was going to machine this part monolithically, right? And I probably spend at least a day on that, if not maybe more, right? Well, here I push the order button, and it shows up a week later for $78, right? So I'm kind of, I mean, obviously I knew this kind of stuff was going on, right? But here's my first part that I've produced, right? So that part's kind of interesting. The other kind of scary part is, if I was a 20-something guy or a 30-something guy, maybe just getting into machining and whatnot, and I saw a part like this, I might be a little bit scared, and because a lot of people are working on this, and it's just getting cheaper and better. So, not that anybody's going to get worked out of a job anytime soon, but it's certainly something to pay attention to, I guess, is what I'm saying. So I'm gonna pull some more parts out here, and we'll take a look at them, and then we'll do a little bit more talking, and then we'll get to some work on this. All right, so there's a little, little bit of a closer view here of the printed lever, and you can see some of the printing artifacts here that are kind of interesting. You know, they stepped up this this ramp here, and then this tapered part of the lever here. You can see the little the different layers, right? So those correspond into vertical layer demarcations or something, and then the final little bullseye there in the ball. So what's interesting here, though, is so now, you know, when I modeled this up, I kind of did it with the idea that I was going to machine this whole thing, right? And you know, I mean, it's not particularly a simple part to machine in one piece, but certainly, you know, challenging and fun, right? You know, from a doing the work standpoint, right? But bottom line is, you know, this is going to take a day or so to screw around with and make, right? Well, now, you know, $78 later, right? Here's one sitting in front of me, you know, pretty much ready to go, right? There's some shrinkage involved with this, so there's some, I would say, some touching up to make things fit. These holes are a little under, and this opening's a little small, so there's a little bit of shrinkage. The process is they use kind of traditional, in these particular guys anyway, traditional printing, 3D printing technology, where they basically squirt drops of stuff down. And there's a binder mixed with the basically kind of powdered metallic stuff, and then they get they get something that looks like this. That's what they call a green state, and then they put it in a sintering oven, and then they heat it up close to, or real close to, the melting temperature, and it kind of homogenizes and comes together. So they're leveraging two technology, the 3D printing technology and kind of the metal injection molding and sintering process to make a pretty solid metal part, right? So it's a real part. So, but the more interesting part here is that, you know, once you know, it frees you from a design standpoint a little bit, right? So, like I said, I designed this with the thought that I was going to machine this, right? Well, now it's like, well, wait a second, that's kind of, you know, hey, I'm not going to machine it anymore. I can add some features that I was thinking about that would be nice to have, and spiff it up a little bit, and there's really no penalty for that. And so the result of that is this. And actually, let's switch drawings here. There's a close-up of that. Kind of see the whole thing there. And then here's the kind of the modified version here, okay? So, you know, I added some more radii and, you know, some cutouts, and I shortened the handle, and I thinned it up, right? And I made this thicker because I said, well, you know, that's going to be kind of a pain in the neck, so I made it thicker, but I really wanted it thinner, so here you go. So, and if you're going to print another one, right, you know, don't print the same thing, print something a little different, and you get to try two iterations here, you know, one crack, right? Now, this one I've done a little bit of work too. Just, I wanted to see what you could do with the finish, you know, and how far you could take that and kind of clean it up a little bit. And, you know, it does pretty good. So this has been filed and sanded and then bead blasted. So I think this is the one I'm going to use here. And maybe we'll do a little torture testing on this one to see how tough that is, because I'm sure folks are curious out there. So, like I said, it kind of frees you up from a design standpoint. Oh, by the way, this was $56 or $53 for this one. And you go, okay, well, it's the same number of operations. Well, it's less material. That's really what, you know, it weighs considerably less than this one. So, so there's no penalty for removing material, right? And which is kind of cool, right? So anyway, that's that part of it. And let's look at some of the other bits that I've started working on, and let's do some work. All right, so here's so there's the chuck I'm going to use. It's a little Jacobs number 0, and now this is a Jacobs arbor here, but it's not long enough and I don't want this relief in here, so we're going to make a new arbor. We're going to make a new arbor and cross drill it and grind the taper on it and everything. So I'm going to set that aside. So what this is I kind of cheated a little bit, I guess. This is it's an old reamer blank, and basically I chopped off the end of the reamer and I bushed it with some hard bronze bushings and put a little vent hole in it there. And now it's got a kind of a factory Morse taper on it. Okay, so here's the rod we're going to use, and what this is Thompson shafting. So it's like 60 Rockwell on the surface, and it's kind of a little bit softer in the center. But why I want to use this is because it has a really good finish on it. So you get that silky feel. Now I lapped this bushing to fit this really well, and for all the people that like this sound here. And in fact, if you hold your finger over that, it doesn't come out, and then if I let my finger off the hole, yeah, so you can, it's a fidget toy for machinists. You can do this all day long, right? So anyway, what we're going to do here is we'll turn this down a little bit and get close to that taper, and then we're going to grind the rest of it for the final fit for the Jacobs chuck. So that'll be kind of fun. We'll dress the wheel at an angle and do that. Let's see what else. And this is I'm going to do this on the rotary table just because it's more entertaining for you guys. And so we'll do that. This is a pretty simple part, this link here. So I don't know. What do you say we get started and do some? And this one I've already fitted that, and you can see as the thing changes angle, right? That's why it's slotted there. So, and then this one is unmodified and it doesn't fit. So like I said, there's some shrinkage here that you have to kind of deal with, but it's probably reasonably predictable within a range, and in this case this allows me to machine this and get just the fit that I want, as opposed to being too loose or wagging around in there. So all right, there's our piece of Thompson shaft. So we're just going to turn the end down and get it close so we don't have to grind so much. Let's see what we're sticking out. Not that much. It should be fine. Zero up on that. Touch off on that. 577. Somewhere in that region. Put a little mark. Now what we want to do is we want to, this is case hardened, so we want to try to get under the case hardening. Let's try that. Looks like it's working. Okay. This is just a little grinding relief. Oh yeah, that looks pretty good. All right, we got our little spinner here. So this is how we're going to spin this to grind the mounting taper, the little Jacobs taper on the end of that. So we're going to go in here, and then we got a little pusher block to sit on top of that. It's always nice to spread the load out there. So we'll dial this in a second. Let me get this set. So how much we're sticking out, I don't want too much, but the wheel's going to come up pretty close here. Yeah, that's probably fine. I want enough to indicate on. So what I'm just going to snug this a little bit now. I want to indicate on this part here, not this part, because really I want what I grind to be as concentric to that as possible, right? So, okay, and you can see that we're clearly not. So let's get a rough setting here. Crack that. And then there's a little rack and pinion deal here. Let's see, where are we here? Okay, that's high, so come down a little bit. Oop, all right, belt's coming off. Still high. Okay, that's pretty good. I think we could do a little bit better with it by eye. So I'm just trying to get it close by eye. All right, that's pretty good by eye. I'm just going to barely take up on that a little bit. All right, let's get the proof of the pudding out here. All right, now that was pretty lucky. All right, so let me see if I can sneak a little snug in there. You guys see that? What is that? 2/10, 1.5 tenths. Can I get it any better than that? So I happen to know that this particular indexer is not dead nuts. So it's got a little, yeah. All right, I'm going to snug it up a little bit. See if we can bop it around a little bit. Oh, that's pretty good. All right, let's put the gronk on that. Oh, that's pretty sweet. You guys see that? Let's see if I can shade that. Stupid thing, man. It's always stupid white face. All right. Okay, so that's pretty good. Okay, let's go over to the grinder, then we're going to dress the wheel for this angle here on this mounting taper, and then, which will be fun because we're going to use a sign dresser, so that'll be neat. And then we'll set this up and get this square with the world on the machine, and then we'll buzz that little taper out. All right, this is our little sign dressing attachment here. Let's take this screw out for a sec. I get this from a toolmaker guy out in Galt, California, a guy named Steve Edwards. Super cool cat, had retired and was selling off some of his homemade tools, and I was lucky enough to get it. There's a little, I've shown these before, but there's this little logo. I love it, and he EDM those in there. Anyway, he made this thing, and he had this kind of interesting style, this kind of big, heavy stuff, but nicely designed. So this is a pretty substantial sign dresser. Anyway, the general idea is that it's a sign bar. Here's the rolls here, and this one's 3.5 inches center to center, and you stack blocks up under this end, and the little sliders. I gotta get it back on there. There it goes. So you're at an angle like this, and then you dress your wheel at an angle, right? So that's what we're going to do. We're going to use this, and here's the diamond. It's got a couple diamonds in it. So first off, let's calculate what the stack of gauge blocks that goes under this end should be with the 3.5 inch roll distance. Okay. Now the included angle is 2.8 degrees approximately. So what we want is we want the half angle, not the included angle. The included angle is both sides. We want the half angle. See that bent finger? So that's 1.4117 degrees according to Hoyle. 1.4117. We'll take the sine of that, all right, and then we're going to multiply by 3.5. So now what we get is we get 0.086227 is what we want under here. Now that presents some problems because to get a 10th increment stack of gauge blocks below 100 thousandths is kind of a pain in the ass. Excuse my French. But what Steve did, he's a pretty clever guy, right? And so he was probably doing stuff with small angles. Oh yeah, there you go. And there's his marks on there. What he did was he created this little trough here, right? So the roll normally lands on this, but what he did was he added a little trough so that you could stack up some gauge blocks. Now I measured this earlier and it's 200 thousandths, okay, and there it is there. So what you do is whatever your number is, you add 200 thousandths to that, so 0.2 plus. So now we're 286,227, all right, which is a little bit better, but it's still not great since the gauge blocks, the 10th increment ones are 100 thousandths thick. So what do we do? Well, in this case, I think what we're going to do is we're going to use a gauge pin. All right, so we'll probably find a 287 minus pin, which would probably put us pretty close to what we need there. So I think that's what we're going to do in this case. And you know, the difference is pretty small, and what we're looking for is a good fit with the chuck to the mounting taper. So let me grab a pin, and then we'll go over to the surface grinder, and then we're gonna dress our wheel off at the 1.4117 degrees. All right, so over here, nice and clean. And then, so we'll get this set up here. We're going to block it in a little bit. This is another block that, this is eBay. This is actually a local guy here that actually was killed in a kind of a bad accident, but a toolmaker guy, and his family sold his stuff off on eBay. Anyway, pretty cool blocks, and he EDM'd his mark in there, which is kind of cool. Thanks, Gary. You know, I always like to, I've said it many times, I like to have stuff that guys made. It's kind of cool. So, now I get the handle off here for a reason, and you'll see that in a minute here. Okay, so we got the dresser on there. So now, the next thing is, we really want to be kind of right over the center line of the wheel. So, how do we do that, right? Well, we can get pretty close, you know, enough that it doesn't really make any difference. So I'm just going to eyeball and get close here. Okay, and then what I'm going to do is slip a little piece of paper in here, like so. And then I'm going to kind of traverse back and forth. And this is the paper is really just to kind of protect the diamond from. And what I'm looking for is I'm looking for that wheel there it goes, right there, just to start moving a little bit, right? Okay, so when I traverse in one direction, I traverse in the other, it catches the wheel, right? So halfway between those 2 points is really our the spot that we want to be at. All right, so this will put us pretty close, and this wheel was dressed, so I'm going to call that good. So I'm going to lock the table, all right, and this comes out, and then this comes out, and then So let's see, what's going to be a good angle to watch this happen? So we'll probably shoot from this direction so you can kind of see what's going on here. And so we're going to knock that off at an angle and get it cleaned up and then do our little grind. I'm just trying to make sure I got it all the way across. Alright, now we gotta do a little bit of alignment on this, so just make sure that it's straight with the world. Alright, so that's getting closer. Alright, let's go back. So, we're just going to this shows you how easy it is to move something on the magnet, right? Actually, you know what? I want to see it a little better for myself here. Actually, let's do that. That's optimal for me. Then I can see it pretty well. Okay. So it's not and I'm tapping it a fair amount because it's not a one-to-one correspondence where it's pivoting from, so you know, you could be here all day. All right. We're getting close now. Probably close enough. You know, for how short this thing is, it's probably not going to make that much difference. But give a machinist an indicator and it ain't on zero, they're going to do something about it. We'll tap our brains out for hours just to try to dial in at a half hour or something like that. All right, we're doing the same thing here. We're just trying to find the center there. But really, we want to be, for this, on center or a little bit on this side towards the camera, right? So something right about there. So I'm going to lock the table, get that out of there. Okay, and then I have a micrometer stop underneath that I'm going to show you here in a sec, okay? And This will allow us to pull this out and take a measurement and then come back into the same setting. So, okay, so we got that. There's our micrometer stop, and it comes up against a ceramic ball there. So we're just going to run that up until it just touches. It's pretty easy to tell right there. All right, so there's our setting. And now what we can do is we can back out and then come up to a positive stop that's accurate. Okay? So here's how we're going to keep track of what we're grinding here. We can measure the big end here, and the spec calls for about 250 right at the big end here. Now this is a commercial Jacobs taper, and it's about 252, something like that. Okay, so we're going to go until we see that, and then we'll do a check fit and see how it feels. And then when we're satisfied, then we'll do a little bluing on there and kind of see what it looks like too before we take it out of the machine. So anyway, that's my story. I'm sticking to it. So let's get to it. 5 spark. All right, so you can see there, you know, there's some run out, right? And so it's catching on one side before the other. So that's why I wanted to dial in on that diameter, not this diameter here, right? This was just to relieve the material. And, but anyway, you can see that it's starting to touch there. So let's continue on. .537, so pretty close. .505. Oh yeah, that's pretty good. Feels good too. So let's blue that and see what it looks like. Let's put a little dicam on there. Well, this is high spot blue. This is actually Prussian blue. You don't want much on here. But you gotta, it's a fine line between having enough on there to get a good contact pattern and one that doesn't influence the reading. So, okay, so we were all clean before we started there, so let's put that on. Give it a little wig. Yeah, okay. That looks pretty, I'm going to call that pretty damn good. It's rubbed off all the way. You know, there's some little high-lows, mismatches in the grind. All right, well, I'm going to call that a success. All right, let's move on to the next operation here. All right, so next up here, we got to poke a hole through the side of this. For a little dowel pin. We want a nice fit on that. So This is 60 Rockwell on the outside of that, so it's pretty hard. So we got a carbide bit here, special for hard materials. Some people call these high rock drills. Anyway, straight flute, real strong. It can take a lot of thrust without deflecting, and it's gonna whittle its way through there. So let's get that up in there, and I'm gonna bottom that out in there. And I'm in position, so we're kind of ready to go here. And my old man specs here. Alright, so let's get a good start here. Alright, and you can see it's starting to cut. I want to make sure I get a good start. Oh yeah, that's pretty good. Double check. Alright. Okay. Now these actually take a bit of feed pressure. Okay, so there I'm through the case hard there. Which isn't that thick. So since these drills don't have spiral flutes, you gotta, if you have a hole with some depth, you gotta keep clearing it out. Now this drill is undersized too, so we're going to have to open this hole up. It's the only one I had. Oh, totally the only one I had. Alrighty, that's an X drill. Well, you know, stuff happens. Now, in general, carbide drills are not a big deal to get out because they're so frangible. The bigger problem here is I kind of don't want to take this out at this point. Right, let me get some better pliers there. Well. Alright, well I got all the busted pieces out of there. I found another drill. We're going to try this one here. It's not my first choice because it's just not my first choice. It's kind of long and it's got the look of it wants to break easy. So let's see what happens here. Well, it's actually cutting pretty nice. Oh, look at that. Beautiful. Now hopefully, pretty sure I got all the bits out of the bottom there. Alright, that feels okay. Not grinding anything hard down there. Have the smell of it's getting hot. For some reason. This one's actually working really good. I'm worried about the breakthrough. Put a stop up against this thing here. I want to control the breakthrough real closely here, so what I'm going to do is I'm going to peck against the quill stop.
So what I'm doing is I just advanced the quill stop a few thousandths, and then I got a nice hard stop to come up against, and it'll control the breakthrough when I pop out the other side. At least that's the theory. So it feels like I'm maybe against it. I don't see anything on the other side. It suddenly got harder. Sounds kind of funny. Okay, so 123 goes all the way. What do we got? 124. All right, 124. It's pretty good. Okay, so, and this is probably, I don't know, a couple tenths over 125. So what we'll do is, before we take it out of the machine, we're gonna lap that hole for a kind of a gauge fit with that pin. So, all right, so we got this is called an eye lap, like eyeball, EYE, because it has a little eye in it. And this is copper. These are real cheap. McMaster sells them. And then it comes with a little tool to help spread it out, to change the size of the lap a little bit. And check that. Make sure it's a little over. Okay. And then what we're going to do is, I got a teeny bit of 20 micron diamond here. We're just going to put a little in the hole, and then put some on the lap, and then we're going to go to town. Get a little going here. You don't need much. It's probably not going to take very long. Put it this way, it ain't going to take long enough to worry about not videoing it. Okay. Slow it down a little. Get smarter here. Take the stupid lap out of there. Let's see what we got here. Oh, yeah. That's pretty good. It's a little tight on the other end. See? It's a little tight on the other end. Darn it. There we go. All right, so pretty close. So what I'm going to do is I'm going to favor that other end a little bit. The other thing I can do is, at this point, I can turn it around and lap from the other side if I so desire, if this doesn't work.